Welcome back. Now let us do clustering hands-on, and please open the file clustering.r. Yes, it has opened. Okay, let us start. In line number 2, we are cleaning the environment. If there was anything previously, it will clean up. Line number 3, setting the working folder. Line number 5, getting the data table library. Line number 6, this is the common util files written by me. And line number 11, we are defining categorical column, and we are going to work with iris. So categorical column name is species, and here we know very well that response variable is also named as species, and the image folder is here so that we can store all the images. Let us read the scale data. And why we are reading the scale data? Because in case of clustering, you saw that throughout it was based on the distance, and when you calculate the distance, if it is a scale data, then everything will be calculated appropriately. If you do not scale the data, then all the heavy weights will be biasing the distance. So that is why it needs to be scaled. And now reading the data of fresh in line 14, and since we are working in unsupervised, and unsupervised, there is no response variable is not required. That is why in line 17 we are dropping the response variable. Okay, and first we are trying to do the principal component analysis, so that we have the data in the PCA format, which we'll use to display cluster. So how it will do it, that let us learn it. So let us do the PCA, and the PCA can be done by this library PRCOMP. This is our data, and scale false. It means no need to scale. Center also false, no need to center, because our data is at the center. So 20, when we do PCA, it has done it. And what it is doing, there is variance. Variance means it has done PCA. PCA has done something that it has converted our 4 variable to some different variable, and it is saying that if you take one component, what is the variance explained, if you take 2 component, what is variance explained, and so on. So that is what this 21 is getting calculated, and 22 we are printing it. So it is saying that instead of 4 feature, if you take only one, 89% accuracy you will get approximate. If you take 2 features, around 98%, and 3 features around 99%, and if you take all the 4, you will definitely get 100%. So this is the way it is saying. And since we are interested in taking 2 means because we'll be using the PCA part to show the cluster. And why to show the cluster, that time I will explain. And we need the 2 component only, so we have to get the 2 component. Line 23 we are assigning the number of components, and here we are trying to get the transform data. So first you see the dimension of our actual train, 150 row 4 column, and the rotation, that is the PCA data, it is the 4 row 4 columns. Okay, and let us see the data head of this is our train data, and this is what the PCA data looks like. This is what I was saying, that you will get the column like this: first component, second component, third component, fourth component. Okay, so this is, and we have already seen the dimension of the PCA. It is 4 by 4. This is the 4 by 4. Okay. Now we are going to do the matrix multiplication, and I hope you recollect the matrix multiplication. How does this really works like? Okay, so let me show you the matrix multiplication. It works in this way. Matrix multiplication, it works in, for the suppose you have M1 matrix, it is having R1 comma C1. Say R1 number of column and C1 number of column, R1 number of row and C1 number of column. And I hope, see, you must have learned the matrix multiplication sometime around 10 plus 2 in your higher education. But if you don't, I'm just refreshing it. And if you have another matrix, say matrix M2, and that is having row 2 and column 2, R2 number of row, C2 number of column. You can do the multiplication provided C1 equal to R2. Okay, and then you will get the result of a new matrix M3 of R1 column and R1 row and C2 column. This is what will be your output. Okay, so similarly, if you see over here, so the number of column is as 4. It is definitely matching the number of row. So definitely we can go ahead and do the matrix multiplication, and that is what we are doing here in line number 36. So let me delete this one because this will unnecessarily confuse you. But matrix multiplication, I know that most of you will be knowing it. I have gently mentioned because few of you may not know. So 33 I'm running it, and 33 it has done it, and let us see the dimension of 33. So that it should be 150 row and 4 column. Yeah, you saw it. Okay, the way I had explained. And if you want to see the head of it, we can see the head of also. Let's take the 2. So I'm running line 35 to just show you the head. So it has given us all the 4 components, okay, but we need only 2 components. So what we'll do, we'll say that from 1 to 2 only give it, and that is what we are putting in the PCA. That's what, because we need only 2, and I'll explain that why do we need only 2. So in 38 we have stored the PCA in 2, and 41 we are cleaning it. That's all. So we have done the PCA, and in next video we'll use the we'll move ahead with the clustering part. Thanks for watching it. See you in the next one.